Today we are going to start introduction to data analysis. The question is, what is data? Data means collection of information, collection of the values in order to use it to get some more requirable value. That is our data. But what type of the data is over here? So here I would like to tell you, because all our concern was related to the superpave gyratory compaction machine. When our specimen is being compacted, here I would like to tell you one thing before I proceed one further. This is my specimen and this is the internal dia and this is the height. And if you see this diagram, it shows that this shape is like cylindrical object. Cylindrical form. When we have the object in the cylindrical form, we can find out its volume pi d square hx. I will tell you what is this hx divided by 4. Here hx is being written just in order to show you that during each revolution or during each gyration, the height of the specimen is being reduced. Height of the specimen is being reduced. But over here, very important thing, that we have put a known mass m of hot mix. Mass m of hard mix asphalt in order to form this one. It means mass is known to us. The volume can be determined by the equation given over here. From these two values, the bulk specific gravity of this specimen at any gyration can be calculated by this ratio. Which is given over here. Let me repeat this again. I am saying the amount of this bulk specific gravity of the specimen can be found out at any stage or any number of revolution or any number of gyration by using this equation. Mass is the mass of the hard mixed part and this is the volume of this specimen which I have given you over here. But here I would like to tell you one thing. Because you see, this surface is actually not smooth. It is like this one. This surface is actually not smooth. It is like this one. When surface is like this, it is known as imperfection. It is not an absolute cylindrical shape. These are the imperfections. Now, in order to find out the value, these imperfections also need to be taken into consideration. These imperfections can be determined can be taken into consideration by correction factor. CF or it can be represented by C only. CF or simply C. Now what is this correction factor? How will we determine it? Just we have to consider it first. As you know that when we were developing this gyratory specimen, there I had told you that we are going to study the height mode, and each height mode is related to the number of gyration. So let us assume that I have already told you about the number of gyration n ini, n dash and n max. These are the three number of gyrations. But over these three gyrations, let me tell you, with this n initial, the specimen is going to possess the height into this mode. It is not taken out, but it is being read from the machine. That is known as H initial. And when it has reached to the design number of gyration, then it is going to possess the height known as H dash. Although I will not use it over here, but it is necessary to tell you that when we have compacted the specimen to this maximum number of gyration, at this, the height of the specimen would be taken as H max. Clear it? Now, my area of study over here is only up to this. Because N max I am not going to study now. Here I have told you correction factor. This correction factor is given by this formula. C is equal to H dash divided by H ini. And I will use this correction factor in order to determine the values of this bulk specific gravity of this compacted mix. But here keep one thing. This height is always smaller than this. Why? You know, when we have put the sample in single lift into this mode, that time it is being compacted. With each revolution, height is being reduced. Here n ini I have already told you that it is having the 8 number of revolution and it is having the 100 revolution. And it is showing naturally when it is being compacted 100 times, the height would be less. When it is being compacted only by 8 round, height will be more. So that is why the value of C is always less than 1. One thing. Now, if I will use this correction factor, how will I determine the value of GMP at different number of rotations? Here now, this I will not tell you. Let us suppose I want to study GMB when my gyration is n ini. How will I write down? This GMB at the rate of n ini, what would be the value of this bulk specific gravity when my gyration is getting to this one? Its formula is this C correction factor into GMB at the rate of n max design. So this is the formula. Let me tell you one thing over here. If we have the 8 number of gyration, with this 8 number of gyration, whatever the bulk specific gravity we want to determine, it is determined C into GMB at the rate of, actually this is the at the rate sign. and design. Clear it? Now, we have percentage of GMM. We have to find out at N ini, N des, and N max. At the rate of N ini. Actually, it is a ratio between this bulk specific gravity C into GMB at the rate of N ini over GMM. Now, what is this GMM? You know, before we have already determined, we have the 3 binder content, where each binder content we have determined the value of GMM. So that bitumen content is being taken for this GMM. For example, here I have taken PB is equal to 4.5%. When PB is 4.5%, the value whatsoever GMM is calculated, it will be considered over here. So rather than writing only 4.5%, so because these are our trial value, so then we can write down at trial PB. Similarly, second factor, percent GMM at the rate and design, it is equal to at the rate of N design, because this is for this design value, divided by this GMB, which we have already considered over here. This value would be written at trial PB. My last equation, N max. When we are considering the N max, here we will have to find out the value of GMB at the rate of N max. But I would like to tell you one thing. Here GMM at trial PB. Please, I would like to tell you one thing. I have written C only in equation. In these two equations, I have not written C. So keep this in mind. Correction factor is only applied when we have the gyration, number of gyration when it is less than 100. When it is equal to the 100, it means we are at the design point. When it is at the maximum, then no need. So that is why in these two equations, C is not being written. So it was this mathematical computation. Now I will use these equations in order to tabulate my data in my next video. Thank you for seeing this.